Hello everybody, it is test review time. Time to review some vectors. So again, just like all test reviews, I'm going to go over everything. So if you are confused on anything or need help, you can always pause, rewind, or if it's just one specific section that you're struggling with, you might want to go watch that specific section's video from when we did that during the unit. But again, I'm going to go through everything that will be on the test. So, and I'm going to go quickly so that the video is not like a million minutes long. So again, feel free to pause, rewind, or whatever as you need to. And if the video isn't good enough, go watch the specific video on that subject. So, first section is it gives me a vector and it wants me to graph it and find its magnitude. It gives it to me in component form, and again, things in component form start at 0, 0, and then end at whatever point this is. Okay, so it starts at 0, 0, and it goes to -3, 7. So that right there is its vector. Okay, that's vector V. Okay, now to find its magnitude, again, Pythagorean theorem. It's the horizontal length squared plus the vertical length. And again, in component form, it's basically just going to be those two numbers. So in our calculator, we would just do in parentheses, right? -3 squared plus 7 squared, which is 58. And then to undo the square, so again, -3 squared plus 7 squared equals c squared. And then you get 58 is equal to c squared, but we want just the longest side, just the c, so we square root. So the square root of 58 is 7.61. It says around the nearest hundredth, so 7.612. Or sorry, 7.62. 7.62. And that's our answer. Okay? And again, -8, -6. So -8, -6 is this point right there. So there's my vector, vector W. Okay, right, that's W. So and again, we just do -8 squared plus 6 squared, -6 squared. Okay, which would be 64 plus 36, which is 100. And then you square root that and you would get 10 as our magnitude. Look at that, I did it in my head. It was a tough one. Okay. Then we have some vectors that are not in component form. So to do these, we start by graphing the initial point. So -2, 4 is my initial point. And then my terminating point is 5, -5. So right there. So that is my vector. Okay? It wants me to find the components and find the magnitude. So again, to find the components, it's just the horizontal length and the vertical length. So this is going over 1, 2, 3, 4, 5, 6, 7. And it's going down 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 7 to the right, so +7, and 9 down, which is -9, right? Right is +x, down is -y. And that would be your components. And then to find the magnitude, it would just be those two numbers squared, added together, and square root. So 7 squared plus -9 squared, which is 130. And then the square root of 130 is 11.40. So 11.4. Because the 1 would not round up to 0. You could put the 0 there, but it's the same as 11.4. Okay? All right, let's try another one. Initial point. That's the starting point. So 6, -7. My graph disappears. Didn't copy very well. Okay, and then -1, 3. -1, +3. So here is my vector, resultant vector right there. And again, you just count. It's going over 1, 2, 3, 4, 5, 6, 7 to the left. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up. So again, left is negative, so negative 7, up is positive, positive 10. Okay, and that would be my components. Now I square those, add them together, it would be 49 and 100, so the square root of 149 is 12.206, so 12.21. 12.21. Okay, all right. Then, next section, story problems. These were very tough, right? Now again, we got to model these, and we've got to find the answer. So, there's a plane flying south at a speed of 110 miles per hour. So, going south at 510. There's an east wind blowing at 120 miles per hour. So, 120 going to the east. Model a situation and find the resulting speed of the plane. So again, we're basically just looking for this line right here, right? So it's just Pythagorean theorem. 120 squared plus 510 squared. So 120 squared plus 510 squared. So just to write it down for y'all. That's going to be 274. 500 equals c squared. But then I want that square root, right? I want to square root both those. So square root of that answer is 523.927. So 523.93 would be my answer. Miles per hour. Okay. Not too tough. Try another one. Suppose a canoe is traveling west. It's going west at a speed of 12 miles per hour with a tailwind. Would wind really mess with the canoe? Well, let's just pretend it does. At 3 miles per hour. It should be like a current. The tail current. Going with the current at 3 miles per hour? I don't know. Anyway, who wrote this? Oh, it was me. Okay, well, fail. All right, model a situation with vectors, find the resulting speed. Again, they're going the same direction, right? So you just add them together. 12 plus 3 is 15 miles per hour. Yeah. Okay, tough. All right, next one. Given the operations, the following vectors by graphing and find the resultant vector. Okay, so this is the one where we're adding abstraction by graphing. Again, you can do this mathematically if you want. At the very least, you should check your answers mathematically. So v plus g. So v is 7 and negative 4. So there's my first vector. Now we're adding, so when we add, we start at the head or the terminal point of the first vector and then just do the components from there. So the next one is negative 5, 8. So 1, 2, 3, 4, 5, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there is my second vector. Now to get the actual vector, you start at the point where you started and just connect it to the end point there and just figure out those components. So it is at 2 and 4. So 2, 4 would be my components there. This little line is v plus g right there. So again, let me just double check this. Again, to do it mathematically, you just add them. So 7 plus negative 5 is 2. Negative 4 plus 8 is 4. Yeah. I did it right. Yay. Okay, subtract them. So this one, basically both start at the origin when you graph them. So 4, negative 6. There's A. And I'm going to label this because it's very important that I do this from a specific one. And then B is 10 is off the graph. I'm really good at making these. And negative 4. Who made this? Goodness. Okay, now to get the resultant vector, or the subtraction ones, you start at the head of the second vector you graph, so vector B, and you draw it to the head of the first vector. And then you just look at the components. So this one is going over 1, 2, 3, 4, 5, 6, and down 2. So it would be 6 to the left and down 2, so negative 6, negative 2 would be what I would get for the subtracting vector. Now again, you just subtract these, so 4 minus 10 is negative 6, so that one's right. And then negative 6 minus a negative 4 would be negative 2. So I did it right. Great. Always good to check. Okay, now this time we're just doing it without graphing. So again, if it's a scalar, if there's a number in front, it's just multiplying those numbers. So like, and it wants me to find the magnitude this time too. So I got to find a couple of things. So first I'm going to find the component, and then I'm going to find the magnitude. So negative 15. Oops. Negative 15 times, and why am I doing this calculator? 60. Okay. And then it would be negative 40. So there's my new components. Component. Okay. Now to find the magnitude, it'd be 60 squared plus, in parentheses, negative 40 squared, which is 5,200, and then you square root, and you get 72.11. So magnitude is 72.11. And there's your answers. Okay. This one, it wants me to scale f and then add it with v. So first thing I'm going to do is I'm going to multiply f by negative 2. So that would be 10 and negative 18. Okay, and that's negative 2f right there. Then let's add them. So to add them, it's just the x's plus the x's. So that would be 15. And then negative 8 plus 11 would be negative 7. So there's my components of my negative 2f plus v. Then, to find the magnitude, I square them, add them together in square root. So 15 squared plus, in parentheses, negative 7 squared, which is 274. And then I square root to get 16.552, which would be 16.55. And there's my answer. Okay. This one I have 3f minus g. So again, start by scaling f. So 3 times 5 is 15. 3 times 10 is 30. So there's 3f. Now I'm going to subtract that with g. So it'll be like 15 minus 0, which is 15. And then 30 minus a negative 7 would be like 37. Okay. So there's my components. And then to find the magnitude, square them, add them together, square root. So 15 squared plus 37 squared. And then square root is going to be 39.92. 39.92 would be my magnitude. Okay. And then this one just wants me to scale it. So 5, 10 is 50. 5, negative 4 is negative 20. There's my components. And then square them, add them together. So 50 squared plus negative 20 squared is 2,900. Square root of that is 53,851. So 53.85 would be my answer. Okay. Yay. Okay. Then, last section. So this section, we've got our rotations using matrices. Again, basically how this works is just the first number is going to multiply with the top number, and the second number is going to multiply with the bottom number. Okay, and I just need to write the components and graph the results. So, negative 2 times 1 is negative 2. And then negative 7 times negative 1 is negative 7. I'm right. Negative 7. And there's my new components. right? So the new vector would be at -2 and -7. There it is. Okay, and it started at -2 and +7. So just to kind of show you, this is the original v, and this is like vector prime or whatever, because it rotated down. It's actually more of a reflection, but whatever. Okay, next one. Anytime it's more than 1, it's going to actually scale it too. So again, 3 times -2 is -6. 1 times -2 is -2. So there's my new vectors, or new components. So the resulting vector is going to be -6, -2. So there's my new vector. That's x prime. The original one was 3, 1. So it was this vector right here. Just this little small one. See, like it grew and doubled. And then it like flipped across the origin, basically. Okay. And then this last section is going to be the level 4 questions. These are the ones you have to get right to get the level 4. Again, the idea here is it's going to give you a shape. So this one gives you a triangle. So triangle 0, 4. I'm going to sketch the points first. -2 and 8. Whoops, not that point. Right there's the point. And 2, 6. So here's my triangle. Okay. Now, the idea here is, again, we're going to find the area. So again, the area of a triangle is 1/2 base times height. Okay. What we're going to do is we're going to pick any point, and we're going to turn the two lines coming out of it into vectors. So if I pick this point, it makes this a vector and this a vector. And I'm going to find its components. Okay, so these are not at the origin, so I have to count how many over and how many up it goes. So 1, 2, 1, 2. So it's going over 2 and up 2. Okay, and I'm going to turn those two sets of components into a 2 by 2 matrix over here. This one is going left 2 and up 1, 2, 3, 4. So -2, 4. Okay, now the idea and why we do this is if I find the determinant of this matrix, the determinant is going to equal the base times height. Okay? And again, to find the determinant, it's just the fish, right? You do the first and last multiplied together minus the second and the third. Okay? So 2 times 4 is 8, and then you minus 2 times -2, which is -4. Okay? Now, 8 minus a -4, again, you add, right, would be 12. That gives me the base times height, but again, the area of a triangle is half that, so then I divide it by 2, and it's going to be 6, is my answer. Okay? Now, does it matter which point I do first? No. If I put -2, 4 on top and then 2, 2, I would have gotten a -8 minus 4 or something like, yeah. Because it would be -2 times 4, which is -8 minus 4. So what would have happened there is I just would have ended up with a -12. Okay? So it doesn't really matter the order you get. You're going to get the same answer, but it might be negative. If you do get the negative number, you just got to remember area can't be negative. So you got to just erase the negative, basically. Okay? All right. Let's try another one. So this one's a quadrilateral. So again, I'm going to plot the points. So -6, -1, and then -1, -6, and then 3, -2, and then -2 and 3. Okay, so here's my quadrilateral here. Just a diagonal rectangle, basically. Again, can choose any point, doesn't really matter. Let's choose this one. And if I choose that point, that means I'm making this line a vector and this line a vector. Just the two lines coming out of it. Okay? Really, you only need to graph 3 points. You don't even need to graph the whole shape to do this. So, then I just count the horizontal length and the vertical length. So this one is going 1, 2, 3, 4 left. and down 1, 2, 3, 4. So those are both negative directions, so -4, -4. Okay, and this one is going left 1, 2, 3, 4, 5, and it's going up 1, 2, 3, 4, 5. So left is a negative direction, up is a positive direction. Okay, so that would give me -4 times 5 is -20. And again, the fish, you multiply those and then subtract those, right? First times last minus second times third. And then -4 times -5 is +20, so you'd minus 20. Okay, now that gives me -20 minus 20, which is -40. So again, I put them in the order that gave me the negative number. I know I can't have a negative area, so again, if I just flip the order, I would get a +20. But that gives me base times height, which is the area of a square rectangle, right? Area of a rectangle is base times height. So that's my answer. That's all I got to do with the quadrilateral. Okay. Again, you have to get those two things right. So if you're confused at all by those, make sure you ask questions. We're here to help. We want to help, and I'll see you guys out there.